You. Today we are going to perform the VI characteristics of the MOSFET. Okay, due to the COVID-19, we are recording this experiment and we will send in YouTube. Okay, please see all of you. Okay, see the what is the circuit diagram for the perform the VI characteristics of MOSFET. Okay, this is the circuit diagram. MOSFET is having three terminals: gate, drain, and source. It is clear. Gate, drain, and source. Clear. Next, to get the output characteristics, okay, to turn on this device, we have to give the supply voltage across the gate and source. Okay, that is the VGS, and as well as we have to apply the supply voltage across the drain terminal as well as source terminal, that is VDS. It is clear. This is the VDS, or also we can call as a VDD, and this is the VGS. Okay, the supply voltage between the gate terminal and source terminal. It is clear. So here we can obtain the two characteristics. One is the output characteristics and second one the transfer characteristics. Okay, to obtain the output characteristics, what we have to do here, we have to put the gate source voltage is kept constant, and we have to vary this drain source voltage, and we have to note down the readings of ID, that is the drain current. It is clear. Means what we have to do here, we have to keep the gate source voltage is kept constant, and we have to vary this VDS, okay, voltage across the drain and source terminal, and by varying this VDS we have to take down note down the readings of drain current. It is clear. See here, this is the simple kit to perform the MOSFET and IGBT characteristics. Here we can perform on this kit we can perform two experiments, that is the characteristics of the MOSFET as well as characteristics of the IGBT. Okay, this is the IGBT device and this is the MOSFET device. It is clear. Gate is the common gate. Okay, emitter and collector, this is the IGBT, and gate, drain, and source, this is the MOSFET. Okay, now today we are seeing the VI characteristics of MOSFET. Okay, no need to any characteristics of the IGBT. Okay, see here how we can perform this experiment. This is the first of all we have to put the pots at zero position, means fully anti-clockwise direction. Okay, like this. Okay, now connect this link between the B1 to B2. Connect this link between the B1 and B2. Okay, and this is the ammeter. Okay, this ammeter is using for the observing the drain current. It is clear. Now this is the load, this is the fixed load, and this is the variable. Okay, whatever we would like, whatever we want, we can take. If we found the fixed load, then we can connect these two links. If we want to variable load, we can connect these two links. It is clear. So today we will see the we will take the fixed load. It is clear. And this is the simple connection diagram of the MOSFET. Okay, and here for giving the supply voltage across the gate and source, okay, we will take the one link. Okay, this one is the link, but instead of this link, okay, I will take the one connector. Okay, this is the connector. Okay, why we have taken this connector instead of this pin? Okay, for getting the measuring the voltage across the gate and source terminal. Okay, by using this pin we cannot we cannot measure the voltage across the gate and source. Okay, that's why we have taken this link. Okay, it is clear. Now put the gate source voltage is constant. Okay, gate source voltage is constant. So how we can vary here? This is the simple connection diagram of the to perform the characteristics of the MOSFET. It is clear. Now turn on the switch, turn on the kit. Okay, it is clear. Now so see the VGS is kept constant. How we can keep the VGS is constant? Put this pot at zero position. Okay, now take the voltmeter and connect this across the gate and source terminal. Okay, this is the voltmeter. It is clear. Okay, now fix gate source voltage at 1, for example 7.0 voltage, 7.0 volts. Okay, this is the now we kept the voltage constant at 7.0 volts. Okay, this is the voltage between across the gate and source. It is clear. Now what we have to do to turn on this device, we have to apply the uh, drain and source voltage. It is clear. Okay, now take the readings of, see here, see this diagram. Okay, VGS is 7.0 volts. Display, this is kept, this is the voltage is constant. Okay, now we have to vary the voltage across the drain and source, and we have to note down the readings of drain current. It is clear. Okay, see here, now vary the voltage across the drain and source terminal. Now this voltmeter now connect the voltmeter across the drain and source terminal. Okay, now vary the voltage across the drain and source terminal, VDS. Okay, observe the current, drain current. Okay, it is clear. 3.7 volts. Okay, the drain current is approach 40 milliamperes. This is the milliamperes. It is clear. See here, 3.1 volts, the drain current is approach 40 milliamperes. Now again we have to take the vary the voltage across the drain and source. Okay, 5.4 volts, and the current will be increased. Clear. Like the same way, vary the voltage across the drain and source. Clear. And note down the readings of drain current. It is clear for a 6 to 7 readings. 6 to 7 readings. Clear. Like the same way, see here, VGS is 7.0 volts. Okay, we are varying the voltage across the drain and source 1.2. At 1.2 volts, drain current is 20 milliamperes. At 3.1 volts, drain current is 40 milliamperes. Okay, at 4 volts, drain current is 50 milliamperes. Like the same way, take the readings of up to 14 to 15 volts voltage across the drain and source, and note down the readings of drain current. Okay, now we can plot the graph between the VDS versus ID. Okay, then we can get the characteristics of output of the MOSFET. It is clear. Okay, this is the VDS versus ID, the output characteristics. Okay, this is the output characteristics of MOSFET, that is VDS versus ID. Okay, now we can draw the graph between the VDS versus ID. It is clear. This is the output characteristics of the MOSFET. Okay, now yeah, now we will check the transfer characteristics. Okay, to check the transfer characteristics, again we have to come to the first step, means we have to put both pots are at zero position. It is clear. Okay, now what we have to do here, now VDS is kept constant, and we have to vary the voltage across the gate and source voltage, and note down the readings of ID. Okay, exactly opposite process, reverse process of output characteristic. Okay, now we have to vary the, now we have to fix the voltage, we have to keep the constant voltage. Which voltage? Voltage across the drain and source. Okay, drain and source. Now we have to vary the gate and source voltage. It is clear. See here, voltage across the gate, drain and source is, for example, 15 volts. Okay, we can take any readings, 13 volts, 12 volts, or 15 volts, whatever. Okay, for example, take one reading. This VDS is kept constant at 15 volts. It is clear. Now see here, see these readings, voltage on the voltmeter. Okay, okay. Now the voltage across the drain and source terminal is 15.12 volts. Okay, this is the constant voltage. Clear? Now vary the gate and source voltage. Gate and source voltage. Now connect the voltmeter across the gate and source terminal. It is clear. This is the common terminal of the source. Clear? Next, vary the voltage across the gate and source. Vary the voltage across the gate and source, and take the observe the readings of the drain current. See at which voltage the device is turned on. Please see the carefully. At which voltage means approximately at 3.3 volts the device is turned on. It is clear? Okay, take the readings of 3.35 and drain current is 10 milliamperes approximately. It is clear? Like the same way we can vary the VGS voltage very small values and take the readings of the drain current. Okay. Okay, 4.7 volts, and take the readings of the drain current 5. Like the same way only 3 to 4 readings we have to note down. Okay, for varying the voltage across the gate and source, note down the readings of drain current. Okay, now see we will get these readings. We can get these readings. Okay, the voltage across the drain and source is 15 volts. Clear? And by varying the voltage across the gate and source, we will get the readings of the drain current. Okay, at 3 point approx at 3.8 volts the device is turned on. Okay, at 3.8 volts voltage across the gate and source, the drain current is 10 milliamperes. Okay, vary the small values 3.98, 25 milliamperes, 4.0 volts, 40 milliamperes. Like the same way 4.19 volts and 80 milliamperes. Okay, now we can draw the graph between the VGS versus ID. Now we can draw the graph between the VGS versus ID. Okay, this characteristics can be called as a transfer characteristics of the MOSFET. Okay, transfer characteristics of the MOSFET. Okay, by keeping the VDS is constant at 15 volts. Okay, this is the simple experiment of the VI characteristics of the MOSFET. Thank you.